Everyone, I'm Salman Ibn Yunus back here in this channel with another video. In today's video, I will talk about Markov decision process. So, what is Markov decision process? This is a framework that involves creating mathematical formulas and models for decision making, where part of it is random and part of it remains in the hands of a decision maker. MDPs have many different applications, such as in robotics, automated control, economics, and even in manufacturing. So in every state in MDP satisfies the Markov property. So in the world of reinforcement learning, the Markov property refers to a memoryless property that is stochastic. Stochastic means a general mathematical object consisting of random variables. When we are not storing a value of a variable, because in each iteration there is a change, we call it stochastic. Without Markov decision process is specifically engineered for modeling sequential decision making within environments characterized by uncertainty and stochastic outcomes. This framework provides a structured methodology for an autonomous agent to interact dynamically within its surrounding environment, assimilate knowledge from the consequences of its action, and progressively refine its decision over time. So the fundamental objective of MDP is to empower artificial intelligence systems to make a series of choices in unpredictable situations, with the aim of maximizing the cumulative sum of feature rewards. This capacity renders MDP an exceptionally potent analytical tool for strategic decision making in complex, evolving, and uncertain operational landscapes. So the concept of Markov decision process were initially laid by the Russian mathematician Andrei Markov in the 20th century. So over time it has gone a profound amount of expansion, particularly with the domain of artificial intelligence, and MDPs now serve as the fundamental theoretical bedrock for reinforcement learning, establishing the formal structure within which RL algorithms operate to enable intelligent agents to learn optimal behaviors. Nearly all problems addressed within the field of reinforcement learning are formulated as Markov decision processes. So this framework is really instrumental in allowing AI agents to evaluate potential actions and select those that promise the most favorable long-term outcome based on anticipated future rewards. So in this video I will show a simple simulation to show how Markov decision process work and to explain some of the fundamental components of MDP. So here you can see a visualizer where there is a tiny agent which will navigate the speed and making choices and collecting rewards and rewards. So if we start the simulation, as you can see, it has their current state is 0, and there is no action taken yet, and so there is no reward received. So if I take the first step, then you can see that this current state has changed and the action taken is now down, and still no reward is received. Total reward is -1. So then the next step is taken, then the current state changes and the action taken is still down, and the reward received and total reward, current reward is -1, total reward is -2, as it is have been accumulated from the previous state. So again, if we take steps similarly, the state and the total reward changes. Now the state changes, current state, and the action taken is now right, and the total reward received also changes, and again another step, and then a final state. So as you can see, the current state is now 3-3, action taken to the right, and reward received is 100, and the total reward, cumulative reward is 95, and current reward received is 100. So now a bit of explaining the what happened above. So each square on the grid is a state, so each of them is a state. It describes the current situation of our agent. The agent is always in one state at a time. Think of it as where am I, so it asks itself at every state that where am I. And the action, from any state the agent can choose an action, either move up, down, left or right. These are the choices the agent can make to influence its future. So the reward, after taking an action and landing in a new state, the agent receives a reward, as you can see here, -1. This can be positive, like reaching the goal, and negative for falling into a pit, or a small penalty for just moving. So if it falls into the pit, it has a penalty of -50, as you can see. And there is another thing called transition probability. When an agent takes an action from a state, it moves to a new state. This is the transition. In our simple world, action always lead to the intended state, or deterministic transitions. But in real world, MDP's transitions can be probabilistic. It is trying to move right, but might sometimes lead left due to the wind. So in real world, it can be in probability. Another example can be that is, a robot is attempting to move forward, might have an 80% chance of successfully advancing and a 20% chance of inadvertently sliding sideways due to unforeseen slippery terrain. So in MDP there is policy and value function, and MDP's goal is often to find the best policy, which is a strategy that tells the agent what action to take in each state to maximize its total future reward. So here you can see the total reward. So the goal is to find the best policy. Policy is basically an equation or a strategy to find the best equation that to maximize the total future reward. The value function tells us how good it is to be in a particular state, or how good it is to take a particular action in a state under a given policy. So basically that's all from this video. Thank you all for your time, patience and understanding.